All right, so 3-5 talks about a lot of stuff that we've really already talked about. And so that's why you're going to see me cutting out a lot of stuff. I'd rather you were starting to work on your homework and some other problems first. So let's take out questions 1 through 3. And I want you to write the converse of this statement as a review. You write the converse. Is the conditional true? Possibly. In Arizona, probably. But do we usually have umbrellas when it rains in Arizona? No. It's like, oh, darn, what's that thing? I don't even know where to find it. So here's the converse. If I need an umbrella, then it is raining. Is that true? Sometimes. Let me tell you that my mother used an umbrella when it wasn't raining. And here's why. She used to have to walk to the bus, and on her way to the bus was a place where there was a bunch of pigeons. And you'd walk, the pigeons would fly, and they'd also do what? Poop on you. So she learned quite quickly to bring an umbrella with her, otherwise she'd get pooped upon. So there's a situation where she needed an umbrella, but it was not raining. Well, I guess it was raining, but it wasn't raining water. So that may not be true. I don't really think that we need to put try on a flashcard and memorize it. When y'all know that trying is 3. And then this vocabulary ought to be fairly easy for you to determine whether it's true or false. A tripod is a stand that has 3 legs. True or false? True. A triangle is a polygon with 3 or more sides. Is that true? False. It's just 3 sides, right? A triathlon is a race with 2 events, swimming and bicycling. False, because it is a race with 3 events, swimming, bicycling, and running. In order to triple an amount, multiply it by 3. That is true. All right. Then we have a new postulate. And this is kind of a okay, no duh kind of postulate. Through a point not on a line, there is one and only one line parallel to the given line. So that's a biconditional. Well, it's almost a biconditional. It's not if and only if. One and only. Wouldn't you agree that if this were my point and this were my line, that there's only one line here that I could draw through point P that would be parallel to the other line? There's an infinite number of lines I can draw through P, but only one of those lines is going to be parallel to the other line. So that might become handy in a proof somewhere. And then this one you already know. So officially you've been given the theorem. The sum of the measures of the angles of a triangle is 180. So what I would like you to do is find the missing measures. I always let the unknown be x. And all this theorem is saying is that x plus 100 plus 30 should equal 180. So you should be thinking of setting up an equation there. That's not the only equation we could have written, but that's what the equation for the theorem says. So go ahead and solve for 10 and 11. Get your answers, share them with those around you. So what did you get for the measure of angle C? 50 is correct, and the measure of angle L? 45. 45, so be careful. There's a couple of ways that you could have done 11. This is just way one. And I was clearly using the theorem. You're going to figure out that in a right triangle, what do you know about the acute? Because there's only one right angle and two acute angles in a right triangle. So what do you know about the two acute angles in the right triangle? They're in this case, they're congruent, but they're not always congruent. They're complementary, okay? So if this is 90, that leaves 90 degrees left over for the acute angles. So you could have instead said, oh, 45 plus x is 90. And you'll start to learn that if you have 45 degrees here, this is a 45, 45, 90 degree triangle. It's going to become a special right triangle second semester. And that's when all the trig fun begins. This one are we good with? Okay. So let's look at, we're not going to answer the questions 12 through 14. We're just going to find all the missing values because this is a typical problem that you might have in your homework where you've got to find the value of x, y, and z. You can use your knowledge of the sum angle theorem for a triangle here. So I would like you to work with people around you and or yourself, and I want you to find all the values of x, y, and z, all the values of x, y, and z, and then talk about it. So go ahead and figure out how you're going to find them. There's vast different ways, but please make sure that you label your work so that you can tell what you did to find each angle. And you do have to find certain angles first before you find the other angle. So I will let you come to that. Give yourself about, I don't know, 3 minutes or so. If you need to phone a friend, not really get privilege of your book. No. Well, this one right there, that one right there is acute and that one's obtuse. That one's acute. Those ones are obviously not the same. That one's acute. Oh, that one's 59. So they're not all going to be the same measure. But you've got 3 triangles there. You've got 2 smaller triangles and a larger triangle. So you use the fact that you have 3 different triangles, an overall big triangle, and 2 smaller triangles with the fact that their interior angles add up to 180.
Both of these combined both of these two equal 180.
Individually. So like for instance, this triangle here, those 3 angles add up to 180. Those 3 angles add up to 180. The outside big triangle, this combined, those 2 combined, plus this add up to 180.
So the point of DDA, that's just what is the measure of DDA?
DDA, then wants you to find the measure of x.
Oh, they're asking me
Because D is your vertex. And the reason why I don't know why they didn't say x degrees. That'd be easier than saying.
Yeah,
But it's just a different way to name it. So when you get your answers, compare them. Everybody should have the same answers for X, Y, and Z. I wouldn't necessarily try to answer the question over there. So because
I don't know
well, don't answer their question. You use your knowledge to find Z. So did you find X and Y first? You can actually find X first. Then if you find X, you can find Y. You can't find Z until you find Y. Oh yeah, you can go outside.
These two are a linear pair there, so you can use one of there. But these two are not necessarily linear because they're not adjacent, they're not a linear pair. But you could use the fact that you could add those together. Yeah, those two together make angle B. And you could add that plus Z equals 180. So if you know X, you know Y. If you know X, you know Y. So these are all pair. What about the C? That doesn't matter. Correct. Correct. I think you can find Z by doing plus 102 behind Z. Yes, definitely.
Okay, so let's look up here. This is just one way. There are a multitude of ways that we could find X, Y, and Z. My way is just one way, and we're going to discuss maybe how you did it as well. So this is what I did. So I started off finding X. I know that this is 43 and that's 59 and that's X. So I added them together. They should equal 180. And so the 49 and 53 was 102. Subtracted from 180 leaves 78 degrees for angle X. And so that's how I got that one. I just chose to find X first. Then doesn't X and Y form a linear pair? Because they're adjacent, they share a side, they make a straight line. And a linear pair adds up to 180 degrees. Well, I just found X, so I substituted in 78 degrees for X. Notice that I'm setting up equations to solve. I want you to start to get in the habit of setting up equations to solve instead of doing scratch work. Scratch work would look like this. Scratch. This is scratch. Isn't that scratch? Well, yes, but it's scratch. There's your algebraic equations. So I substituted in the 78 for X, and I subtracted it from the 180, and I got 102. That's not the only way that you could have found Y, but it's a different way, so I thought I would point that out to you. Then to find Z, if I now know Y, these three angles here add up to 180, so I added the three angles together. I substituted in the 102 I found for Y. 102 plus the 49 is 151, so I subtracted that from 180 to get 29 degrees for Z. What was another way that you could have found Z first? Dominic? The whole big outside triangle should add up to 180 degrees as well. This angle right here, angle B, is made up of two different angles, 43 and 49. So you would have had to add 49 plus 43 for that one angle, plus the 59 degrees for angle A, plus angle Z. That should add up to 180. So you could have found Z first by doing that. Once you found Z, then you could have found Y. Once you found Y, you could have then found X. Or you could have found X independently from finding Y. You didn't have to make the conclusion that X and Y were a linear pair. Anybody do something else that was vastly different than that? Okay. I numbered my work so that you could see what order I found things in. And you might want to do that for your own knowledge so that when you go back and study a particular problem, you can remember the progression of how you found it. All right, I just find there are questions on here a little confusing as to how they were asking it, so that's why I ignored those. All right, so this is a very useful theorem. Theorem 312, which is your exterior angle theorem. So you need to know what is an exterior angle and then what does the theorem say. So an exterior angle is an angle formed by a side and an extension of an adjacent side. So right here, this is your exterior angle. It's outside the triangle, that's why it's exterior. It is made by lengthening one of the sides of the triangle, extending one of the sides of the triangle. So I could actually have 3 exterior angles on this triangle. So if I extended this side right here, this right here would be an exterior angle. If I extended this side, well, this side right here is being extended also, so this could also be an exterior angle. I could have extended this side over here and made that an exterior angle. So there's all kinds of ways that you could do it. Now here's what the theorem says. And this is the important part, so I'm going to use my other color. So the measures of each exterior angle of a triangle equals the sum of the measures of the 2 remote interior angles. So here's how you tell what a remote interior angle is. Aren't there 3 interior angles of a triangle? True or false? True. So if this is my exterior angle, isn't the interior angle that's touching angle 1 this one right here? So what I typically will do is I will find the exterior angle and cover up the interior angle that's touching that exterior angle. The other 2 angles, in this case 2 and 3, are your remote interior angles. So what this says is angle 2 plus angle 3 equals a measure of angle 1, and I'm going to prove it to you. Let's go back to what we just did. If you look at triangle BDC, let's look at triangle BDC, and I'm going to extend this right here. Wouldn't angle X be exterior to triangle ABC? Right? And what this theorem says is that the measure of angle X, can you see that? Nope. The measure of angle X, that's your exterior angle, is equal to the sum of the 2 remote interiors. So there's my exterior angle. I'm going to cover up the interior angle that's touching it. Wouldn't that be angle Y? So what are the 2 remotes? Well, not B, but the 49 degrees, right? So it would equal 49 degrees plus whatever Z is. So we now know the measures of X and Z because we found them earlier. So the measure of X was 78 equals 49 plus, and the measure of angle Z we found was 29. Does 49 plus 29 equal 78? Yes, it does. Doesn't 78 equal 78? So the theorem is proven true. That's just one example. I could do a multitude of examples, but that's why we know that. It's just a nice little coincidence. It's not really a coincidence since it's a theorem. But on here, we want to add in that angle 1, the measure of angle 1, is equal to the measure of angle 2. And that's what you've got to start to be able to see and set up as an equation. So I want you to set up the equation that looks just like this for each of those pictures there. Figure out which one is the exterior angle and set it equal to the sum of the 2 remote interior angles. So go ahead and write. Write. Now I will tell you that usually all the angles are going to be labeled. They've only labeled 3 angles on these pictures for you, correct? So we're making it fairly simple. but you're going to have all the angles labeled so that you'll have to know which are the remote interior. So these are the equations that you would set up. You're going to know 2 out of the 3, or you'll have the ability to find 2 out of the 3, and then you can use this theorem to find the third. It's a theorem that you often forget about, so I'd start doing it. All right, then we are going to look at problem 2. And I'm not going to answer all their crazy questions down here. So we know that the interior angles that are labeled 53 degrees must be the ones that are the same. 53 degrees, 53 degrees. I want you to label the exterior angle adjacent to the 53 degrees as X and Y. There's 2 angles that are exterior to the 53 degrees. I label those as X and Y. It doesn't matter which one you put as X and which one you put as Y. These can be interchanged, that's fine. And then you're going to label the third exterior angle as angle Z. Would that be the third exterior angle? And so now we're going to find X, Y, and Z. So I want you to find X, Y, and Z. Given that information. Don't answer their questions down here. It's a little crazy. You just use your own words. Use whatever properties make you happy. And share your answers with those around you. Say that again. What do you mean 1 and 2? Oh yeah. Yes, you can name it A. I missed that part. I named it blank. But yes, you're right. Okay. So let's look up here. This is just one way that you could have answered the questions. I happen to use the external angle theorem nearly every time, with the exception of finding this blank one here, which Zoe mentioned that we're supposed to name it A, which she's right. I name mine blank. So I started out with finding all the interior angles first. So I know that the sum of the interior angles is 180 degrees. So I have 53 plus I don't know is equal to 180. The 53s add up to 106. When you subtract that from 180, you do get 74 for angle A, which is that blank angle there. And then I went ahead for X, Y, and Z, and I just used the external angle theorem for all of them. You didn't have to. You could have used linear pair, right? So You could have said that those add up to 180, those add up to 180, and those add up to 180, but I wanted to show you what the external angle theorem said. So for x, that's my interior angle, so the two exteriors are 74 and 53, so that's why I added the 74 and 53, and you get 127. And then for y, cover that up, the exterior angles for y are also 53 and 74, so I added those together, and it makes sense that they're the same if their linear pair angles are congruent. And then for angle z, cover that up, its remote interior are 53 and 53, so I added those together and got the 106. Are you okay with that? Okay. All right, so then flip it to the back, and you've got one last problem to do. So I want you to do, you're not going to answer the questions, but you're going to find the measure of angle x. Don't answer the questions, 23 through 25, just find the measure of angle x, and then we'll be done. Set up an equation, don't do scratch work. What'd you get? What'd you get? 60? What's... Is it 50 or is it 60?
I have no idea.
What was your equation that you set up to solve?
30 plus 10
Okay, what are your two remotes? Your 80 is your exterior, so what are your two remotes?
Oh,
There you
it's
go.
on the outside.
Yeah. So 80 is your exterior angle, right? So cover that up. Your two remotes are 30 and x, so those are the two you should be adding together, and they should equal the one that's on the outside of the triangle, which is the 80 degrees. Does that make sense? And so then you should be subtracting 30 from 80, and that's how x ends up being